In this fourth class of Chapter 7 of the course of Basic Geometry, the following topics are presented: definition of the parabola curve, construction of the parabola, tangent to the curve of the parabola, other definition about the parabola curve. In this first slide of this fourth class and last class of Chapter 7, which is the last chapter of this course of Basic Geometry, a parabola curve is presented in figure 7.13. The parabola curve is a curve of the group of conic curves, since it originates from a section of one cone truncated by a plane. In the case of the parabola, the angle of the plane with respect to the base of the cone is equal to the angle of the generatrix of the side of the cone with respect to the base of the cone. Parabola is a curve whose points have an equal distance from a fixed line called the directrix of parabola, represented by lowercase letter d, and a point called the focus of the parabola, represented by the capital letter F. The point A, which belongs to the curve, is in the middle distance between the focus and the point D that belongs to the directrix D of the curve of the parabola. All points on the curve are symmetrical with respect to the line segment DF, which is called the axis of the parabola. Point A belongs to the axis of the parabola. Point A is called the vertex of the parabola curve. The second slide from the fourth class of Chapter 7 presents the procedure for constructing the curve of the parabola. Figure 7.14 presents the curve and the details of its constructions. The construction begins by drawing the line segment horizontal DF, called the parabola axis. Next, the point D is then marked on this line DF. Now, at the point D, draws the segment of a line perpendicular to the axis of the parabola. This segment of perpendicular line is called directrix of the parabola and is designated by lowercase d. Following, the upper point F is marked on the axis. This point is the focus of the parabola. By dividing the line segment DF into two equal parts, the point A, which is the vertex of the parabola, is marked. This slide continues to present the method of constructing the curve of a parabola. The figure 7.14 is displayed again. On the axis, just to the right of the point A, are marked a set of points, in the example, point G and H. Line segments perpendicular to the axis are now drawn at the point G and H. With center in F and distance dg are drawn the arcs of circumference that cross the straight line that pass through the point G, determining the points M and N that are points of the curve. The points M and N are equidistant from the point F, and the straight line segment D that is the directrix of the parabola. The process is repeated for the segment of a line that pass through H, determining the points R and S. Those points also respect the rule that the points of the curve must be equidistant from the focal point F and the directrix of the parabola D. Using points M, N, R, and S, and more the point A, the parabola curve is plotted. This slide shows the definition of the segment of a line tangent to a point on the curve of parabola. The figure 7.15 shows the parabola curve and the straight line segment T tangent to the curve at the point M. The tangent to the curve of the parabola at a given point is the bisector of the angle formed by the radius vector that connects the point to the focus F with the perpendicular drawn from the point to the directrix of the parabola D, in the example the line segment tangent T at the point M. The locus of a point is symmetric to the focus f of the parabola with respect to the tangents of all points in the parabola is the directrix of the curve of the parabola. An example is the R point. The locus of the projection of the focus point of the parabola on the segment of tangential lines forms the segment of a line tangent to the curve at the point A, the line segment TV. This last slide of this course of basic geometry presents some additional definition concerning the parabola. A first definition says that any point is within the curve, belongs to the curve, or is outside the curve, according to its distance to the focus is less, equal, or greater than its dimension up to directrix of the parabola curve D. The second definition says that any two points in the parabola are symmetrical with respect to each other with respect to the parabola axis, if the line segment connecting the point is perpendicular to the axis. The third definition says that the parabola is a convex curve, that is, any segment of any line does not intersect the curve in more than 2 points.